semiconductors, we provide calibration to meet their production line, to meet their demand to the factory, to the market. We calibrate the major domain of the measurements like temperature, force, pressure, humidity, right? So that's the role in our calibration for the semiconductors. In semiconductors, they have very tight tolerances that we need to measure to meet the production from the factory to the market. So to align the scheduling between production and to the calibration, so that no hiccup in the production line. Over the times, the calibration in semiconductor, the demand is getting higher, especially when the new products coming out from the semiconductors, right? We need to meet the demand of the new tolerances, new specification of the products. In semiconductors, the tolerance is very tight. That's why we need a better standard that to meet their tolerances. The trend in calibration for the semiconductors relies on the data acquisition, because I see that the semiconductors should see the calibration as the strategic investment for the quality rather than the compliance. The way we're doing calibration in future, it should not just periodic check of the component of the calibration, but it's going to be like a continuous measurement or online measurement from lab to the factory. Basically, the trend happened worldwide. The more stringent standards, high accuracy of the parts and components. So we start with for example, the wafer production to the testing of the final product. The trend is getting more stringent over the years. Since we are backed up by the national lab and MIM, so the semiconductors industry can trust us in the services because this national lab is traceable to the international, and we ourselves, our standard is traceable to the national or international standard. So with this availability of the investment, the downtime, the reliability of the calibration, of course, it can be improved. We offer calibration for the major domains of the measurements, like temperature, force and pressure, electrical, radio frequency. We also provide the on-site calibration for the semiconductors. And we do also provide the consultation to meet the standard like ISO IEC 70025 to the client. One success story that we have in semiconductors, where client facing a yield inconsistency due to the unverified process thermocouples, right? We have a precise temperature calibration. This client improved the measurement of the reliability by 15% and reduced the downtime by 20%. So this has enhanced, right, their production efficiency and quality assurance. In recent year, we have invested in advanced thermal and RF calibration system, high precision mass comparator, and also on the automated environmental control chambers to improve the stability and repeatability. Our lab also ongoing on the digital traceability and the reporting system. For semiconductor industry, we planning to expand our calibration scope. So this include on the in situ calibration and also on the digital calibration certification for the semiconductors. And also on the metrology data analysis, this need to be done. For example, if we trying to do as AI traceability, uncertainty, so on and so forth for the semiconductors, right? This should support the client in the productive quality and also in their ESG plan in the company. Over the next 5 years, SIRIM calibration aims, right, to be the regional benchmark in precision calibration for advanced manufacturing for electronics. Our strategic goals also include expanding the international accreditation scope. So by integrating also the AI-assisted calibration analytics and strengthening our digital infrastructure. there are ways, right, to do the calibration remotely, where the equipment in the factory and our standard is in the lab. What the company gonna do, basically, to allow us to connect their system, their whatever equipment that need to be calibrated, link up to us, so we can do remotely from the lab here. And this has been done for the time measurement. We are collaborating with National Lab for the time measurement, where currently they can measure our time frequency here. They can measure remotely from the lab back in Sepang. The government should have this ecosystem, right, for the semiconductors in Malaysia. In the ecosystem, there are manufacturers, there are calibration players, there are regulators that govern the ecosystem. For example, in the infrastructures, the regulatory, and then the skill of the workers, right, in calibration, right. We can have the pipeline of people, right, that can have to continuously support the calibration industries. The calibration must also evolve. The evolution basically to do the calibration not just on the periodically schedule. It's going to be like a continuous verification of the equipment that need to be calibrated. So the collaboration between these manufacturers, the calibration house, and the regulators, right, to ensure that the sectors remain competitive globally. This can make the ecosystem much better in future.